Okay, so hopefully it's recording. This is 2.7 of Zumdahl and Zumdahl's chemistry. Still don't know if I'm saying the name right. I'm doing this on Notability so that way I have access to annotate a periodic table. If you've taken, any science class, this is a college level class. In high school, I'm sure you've learned of the periodic table, but so this video kind of this section serves to refresh your mind on just some of the key things. So this is a periodic table. There are essentially 118 elements that we know of, right? So we talked about how elements are really just sort of classifying atoms based off how many protons they have. So for example, boron. Boron classifies all atoms with 5 protons, right? So in our universe, atoms can have I guess in our universe naturally it's not 118, but we know of atoms that can have up to 118 protons. That's what this atomic number tells us. So this you can get on any periodic table. This kind of tells you the atomic number, the atomic mass. So the atomic mass gives you insight into protons and neutrons. There's going to be a little bit of a decimal because of two things really: mass defect as well as electrons. You don't need to really worry about it. But for example, nitrogen, it's 7 is the number of protons, and 14 basically, 14.007, round to 14, that's its atomic mass. So I know there's going to be 7 protons and 7 neutrons because that's one proton is roughly the same mass as one neutron. Hopefully, I always mix up words. So neutron, yeah, I'm saying that right. Okay. Couple things. Most elements are metal. So this line that I'm about to draw right here, things to the left of it are generally they're metals, and things to the right are non-metals. So let's just talk about metals real quick. So metals, they are generally conductive, so both thermally and electrically. I'm just gonna, you know what I mean by that. They're conductive, they're malleable. So so if you think about like hammering it and like hammering a metal into a sheet of metal, essentially, they're ductile, so they can be pulled into like sort of ropes and wires almost, and they tend to lose electrons. So in a reaction, they may lose they tend to lose. They tend to lose electrons, and because of that, they would become cations, right? Because cations are positive ions, and when I lose electrons, you become more positive. So nonmetals are essentially not these things. Like that's, they're not conductive, they're not really malleable, they're not really ductile, and we'll kind of learn throughout like why this is the case, like kind of understand why. There's reasons for this, and hopefully we'll start to understand why. But this is right now just an introduction to the periodic table. So the elements are grouped such that these columns. Now there is a word. I'm pretty sure a column is a group. I know that a row is a period. So this is a period that I've just circled right here. I'm pretty sure this is a group. A vertical column is a group, I think. I could be wrong on that. There are names for these groups. So right here, these are your alkali metals, right? Alkali metals. These are your alkali earth metals, that sort of thing. Non-metals. That's not, I'm a little colorblind actually, sorry. I thought these were the same. And that's a fun fact if you didn't know. I'm actually colorblind. I just realized these are not the same color. But these are your non-metals, these are your noble gases, right? So like each column has similar properties. So these alkali metals right here, they tend to be very active. They tend to react with a lot of things because they only have one electron to give away. We're gonna learn more about valence electrons. So this numbering system, you have 1A, 2A, and then it goes all the way to 13. It turns out that, well, you could just call this 3A, 4A, 5A, 6A, 7A, and that essentially tells us about something called your valence electrons, the amount of electrons on the outer shell. I believe it's not Lewis dot structure. There's a name for this. If you've there's a name for, maybe it's just the shell model. I don't know. Essentially, if you take something like boron, so boron would have 5 protons, 5 neutrons, which I could make black. So this should be 5. And then because it's in row 13 or column 13, it would have 3 valence electrons. Now, I drew 2 shells. How do I know there's 2 shells? Well, it's because it's in row 2. So the rows tell you the amount of shells. It's a little abstract because, I guess a shell is sort of like the orbital ring. So it goes 2 and then 3, like so. And I don't know if there's a rhyme or reason to the electrons just yet, but there's a name for this. I forgot what it's called. But the point is, the periodic table, it's grouped in such a way to kind of tell you these things, right? It's really nice. Like noble gases, they're not very reactive because their outer shells are typically full, and we'll learn more about that. This is just an introduction. So hopefully this video gives you just a little bit of insight into just the basics of the periodic table. You'll pick it up more when we start learning about more chemistry. So yeah, thank you for watching.